Help us save a family of 10 from homelessness. You have no idea how much your support means to us. Your subscription would honestly change everything. Hitting that subscribe button isn't just a click, it's providing a decent life for them. Ever wonder what the most expensive stuff in the universe actually is? It's a substance you'll barely find a speck of here on Earth, and get this, a single gram of it is worth way more than the entire economy of most countries. How could something even exist with that kind of price tag? And why on earth are we spending billions just to make it? Let's dive into the wild world of the most expensive material on the planet. Just imagine a substance unlike anything we've ever known, a material that would trigger a massive explosion the second it touches anything around us. We're talking about antimatter, specifically antihydrogen. When regular matter meets its antimatter counterpart, everything just vanishes into pure energy, like the universe is literally erasing itself in a heartbeat. This wild phenomenon was once just a prediction in theoretical physics equations, but now it's a reality we're actually working to produce today. Scientists have estimated that a single gram of antihydrogen would cost around $62.5 trillion based on the latest data from 2024 and 2025. That insane price tag is thousands of times higher than the entire budgets of some countries. So why is it so ridiculously expensive? Because it takes an absolutely massive amount of energy to produce, along with cutting-edge tech we've only just mastered, and super high-tech labs that you'll only find in a handful of elite scientific centers around the world. To wrap your head around that number, just compare it to the entire global economy. The world's gross domestic product in 2025 is estimated at about $113.8 trillion. That means a single gram of antihydrogen is worth more than half of everything the world produces in a whole year. Just imagine, every single good and service produced by humanity over 6 months doesn't even equal 1 gram of this bizarre stuff. But did you know that some older estimates were even more extreme? Some scientists actually put the price tag for a single gram at up to $2,700 trillion. That number is honestly impossible for the human brain to wrap around. Like, how can something so incredibly tiny be worth that much? It's all because producing antimatter requires massive particle accelerators, millions of hours of operation, and enough electrical energy to power entire cities. To give you an idea of just how brutal the production process is, the folks over at CERN have only managed to scrape together tiny amounts of antimatter. Honestly, everything they've produced after years of non-stop work wouldn't even keep a single tiny light bulb glowing for more than a few seconds. It really shows that making this stuff isn't just about throwing money at it. It's a massive, epic technical and scientific challenge that takes thousands of brilliant minds from all over the globe working together. So what exactly makes antimatter so incredibly dangerous? Well, the second it touches normal matter, even just a single molecule of air, it triggers an instant reaction that releases a massive burst of energy. This energy output is thousands of times greater than anything you get from regular chemical reactions. That's exactly why storing antimatter is such a nightmare. It requires insane high-tech magnetic fields to keep it perfectly isolated, preventing it from ever touching the walls of its container or any stray air particles. And here's a super wild idea, the potential for using antimatter as a legit power source in the future. When matter meets its antimatter twin, 100% of its mass turns into pure energy. That's a total game changer compared to regular nuclear power plants, which only convert a tiny fraction of mass into energy. If we could actually figure out how to store just 1 gram of antihydrogen, it could power a massive city for days on end, all without a single drop of harmful emissions. Scientists are also throwing around the idea of using antimatter to fuel spacecraft. Just imagine a ship tearing through space at insane speeds, powered by just a few grams of antimatter. That tiny amount could rocket a craft across distances way further than anything our current engines can handle. NASA and other space agencies are actually looking into this, because it could slash the travel time to Mars from months down to just a few weeks. But are these applications actually doable? Honestly, we're still miles away. The biggest hurdle isn't just producing it, it's the storage. We have to keep this stuff in a perfect vacuum at temperatures near absolute zero, all while holding it in place with insanely powerful magnetic fields just to keep it from touching anything. These conditions are only possible in highly specialized labs, and it takes so much energy just to keep it stable that practical use right now is just impossible. Scientists have actually come up with a clever way to trap antimatter using something called a penning trap, which uses a combo of electric and magnetic fields to snag charged particles. But here's the catch. That trap can only hold microscopic amounts. Neutral antimatter, like antihydrogen, is way tougher to pin down because it doesn't react to electric fields at all. That really turns up the heat on the challenge and means scientists are going to need some seriously fresh, next-level solutions to crack this code. And here's the kicker. Antimatter isn't just some sci-fi concept, it actually happens in nature too. When cosmic rays smash into Earth's atmosphere, they kick up tiny amounts of antimatter. Even certain radioactive processes deep inside stars crank it out. The problem is that these bits vanish the exact millisecond they hit regular matter in our atmosphere, so we never see or feel them, even though this wild stuff is happening all around us every single day without us even realizing it. Antimatter has been totally blowing scientists' minds ever since Paul Dirac first predicted it back in 1928 with his legendary equation. Here's the big question though. Why is the universe made of matter when there should be equal amounts of antimatter? It's basically the biggest unsolved mystery in modern physics. I mean, if the universe had kicked off with equal amounts of both, everything would have just annihilated itself instantly. So, something definitely threw that balance off, and we're still out here hunting for the answer. Studying antimatter is also helping us unlock the deepest secrets of the cosmos. By comparing the properties of matter and antimatter, we're able to put fundamental physics theories, like relativity and quantum mechanics, to the ultimate test. Experiments have shown that they behave almost exactly the same, except for some tiny subtle differences that might just be the key to figuring out why we're even here in this physical universe in the first place. So to wrap it all up, antimatter remains this massive scientific dream that we're all really hoping to make a reality one day. It's a constant reminder of just how capable the human brain is when it comes to decoding the secrets of the universe, no matter how tough those mysteries are. Ever since we first discovered it and figured out how to cook it up in our labs, we've been making progress step by step toward a future where this stuff could actually be our go-to source for clean energy or the fuel that takes us deeper into space. But until that day finally arrives, this most expensive material in the universe will keep standing as a total masterclass in patience, science, and pure ambition.